In this example, we're going to answer a series of questions about a polynomial function that we have given as a graph. Part A asks over which intervals is the function increasing, and we need to list all of the ones that are shown on the graph. So the first interval of increase is this one right here. So the function is increasing if when x values are increasing, the y values are also increasing, which is what's happening for these two intervals. When we're writing these intervals in interval notation, we're only looking at the x values. So for this first interval, x starts at -2 and ends at 3. And then the second interval starts at x equals 7 and goes all the way up and to the right, so positive infinity on the x values. Parentheses only over here, the actual points, -2, 3, and 7, they're turning points, so the function is neither increasing nor decreasing at those, therefore parentheses and not brackets. List all x values where the function has a local minima. So local minima happens when the function switches from decreasing to increasing. So this is a local minimum, and this is a local minimum. We just need the x values of those 2 points. X equals -2 and x equals 7. What is the sign of the leading coefficient of this function? Now that is determined by the ends of the function. So I have left end pointing up and right end pointing up. So this is what your end behavior looks like. This is an indicator of a positive leading coefficient. Now part D, which of the following is a possibility for the degree of the function? And we need to circle everything that applies here. Now the smallest degree, the least degree, is determined by the number of turning points that we have. So let's count the turning points. 1, 2, 3. It's where the function switches direction. That's the turning points. So the least degree is the number of turning points plus 1. So for us, the smallest degree would be 4. So we'll circle 4. But really, after we determine the smallest degree or the least degree of the function, every other even degree is a possibility. So 6 is also a possibility for this graph, and 8 is a possible degree for this graph. Now let's try an example with a different function. So this time, over which intervals is the function decreasing? So this time, as x is going to the right, y should go down. It should actually decrease on the y value. So this interval right here, this interval right here, and this interval right here, there's 3 of them. So once again, we're looking for x values only. So that is from -9 to -6. Then another one from -2 to 2. And one more from 6 to 9. List all the values where the function has a local minima. There's several of those. So this one, and this one. Local minimum, and local minimum. Just the x values. X equals -6, x equals 2, and x equals 9. What is the sign of the leading coefficient? So again, we're going to look at the ends. We have the left end going down and the right end going up. This way, this way. This is the end behavior of a function. This also is a positive leading coefficient. Now the degree of the function. So again, the least degree, the smallest degree that it can be. Let's go ahead and count the number of turning points. 1, 2, 3, 4, 5, 6. So the smallest degree that it can be is 6 plus 1, which is 7. So this is our smallest degree, but every other odd degree is a possibility. So 9 is also possible.